All right, good morning, everyone. Welcome to our second day of doing live streams. This is HPC in the cloud. I'm Joe Schoonover from Numerics. Today we're going to be walking you through how to set up your own auto-scaling Slurm cluster that will scale to Google data centers worldwide. Before we begin, just a few steps you should probably take if you want to follow along with the demo if you haven't done so already. First, you want to go ahead and create an account at console.cloud.google.com. And when you sign up, if this is your first time, you'll get $300 trial credit, which you can apply to today's demo, of course, where you'll only be spending about $2 to spin up this cluster and do the sorts of things we're going to be showing you how to do today. In addition to creating that account, once you have your account, you'll have a console that looks like what I'm showing you here on the top left. And you'll want to go ahead and enable the Compute Engine API. So let me show you how to do that real fast. Once you're on the console page, you'll go up to the Products and Services menu. You can either click on Compute Engine, or you can go down to APIs and Services, enable APIs and Services, search for Compute Engine, and you'll see the Compute Engine logo down there. Go ahead and click on that, and mine's already enabled, so it's not showing the enable button, but you should see something that says enable here. You can go ahead and click on that and let that start spinning up. The next thing you want to do, we're going to configure what are called identity and access management policies. These are rules on Google Cloud, on your Google Cloud Platform project, that can protect your resources. You're essentially aligning different roles and permissions with Gmail addresses or G Suite accounts, any registered user essentially on Google Cloud. What you're going to need today in order to perform the activities we're going to are the Compute OS admin login role. This will give you the ability to SSH into your cluster and be able to escalate to root privileges on a Linux VM. And then you're going to need service account user role to go along with that. So to enable those permissions, you'll click again on that Products and Services menu, go down to IAM and Admin, IAM. Okay. Once you're at this page, you can hit Add, put your email address. If you're working with other folks in your organization today, and you're while you're following along with this demo, I'll show you what you want to add for them as well. Go ahead and put the email addresses in here. Okay. And then for the role, again, we're going to do Compute OS admin login. Now you'll notice there is a Compute OS login. This is almost the same thing as Compute OS admin login, except that the users who are assigned this role, Compute OS login, just won't be able to escalate to root privileges on the system. So if you have people you just want to have access the cluster and just use the Slurm job scheduler to submit jobs, that's probably a good role to go ahead and give them. For those of you who are doing the demo today, Compute OS admin login is what you're going to need, because you're going to need to go root. In addition to the Compute OS admin login, we're going to go ahead and add that service account user role. Okay, so if you type it in, you'll see it come up down there on the search list. Then you'll hit save. Now that we're done there, I'm going to go back to the home. Yeah, I've already had this policy applied to my account, so no change on my end, but yours should go through no problem. All right. And we got two more steps to take care of here. So now at this point, you've created your account and you have $300 trial credit. You have your identity and access management policy set up, and the Compute Engine API is enabled, or it's in the process of being enabled. You're also going to want to download and install the Google Cloud SDK. This is a command line tool that you can run on your system to interact with your Google Cloud Platform projects. Essentially, what you want to do is once you install that, you'll initialize that SDK so it's registered to be used with your Google Cloud account. It could be a Gmail account that you're using. You'll basically want to run through the install and initialization process. The only thing we're going to need this for today is to be able to attach SSH keys to your Google Cloud account. The reason why this all happens is if I go back, let's go back for a second here and talk a little bit about that OS login permissions that you've added. So OS login is a service on Google Cloud that basically will pull information from your cloud identity profile, which is a profile that's attached to your email account, to provision like a Linux username, a home directory, and all that stuff for you when you enter or when you log into a Linux virtual machine. And all that handshaking is done so like that you can SSH from a typical terminal from Mac or Linux, or if you're using PuTTY on Windows, you'll be able to SSH as you normally do to any other HPC cluster. And the way the authentication is done is through SSH keys. So to add SSH keys to your profile, so one, if you don't have an SSH key, here I'm showing you the command to create an SSH key on either Mac or Linux. You'll need to create an RSA key. So if you're using PuTTY, make sure when you're generating that key that you're generating an RSA key, and then it's compatible with OpenSSH. It'll make your life pretty easy there. So you'll run SSH keygen -T for type, and then RSA. Now I've already created an SSH key for myself, and I don't want to overwrite what I already have, but here you'll go ahead and run that command. And then once you have that key created, you'll run gcloud compute os login SSH keys add -- key file. All right, so then you'll pass it the path to wherever that key file is stored in your system. Now, if you've used the default path for your SSH key, it'll be in your home directory. It'll be in a hidden directory called .sh, and then under the path id rsa.pub. And again, if on my side, I've already attached a key to my account, so I'm not going to run this. But from here, you'll go ahead and do that, and at this point, you'll have an SSH key, or the public SSH key, aligned with your cloud identity profile so that you can SSH from your terminal. Now what we're going to do with all this done and set up is we're going to go ahead and create the cluster. And so let me give you a little bit of background here. So there are a number of solutions out there for doing HPC on Google Cloud. And what I'm showing you today is how to create an auto-scaling Slurm cluster from Google Cloud's marketplace. This is a click-to-deploy solution that we've developed off of a open source repository from SCEDMD that's available to everyone. So you have a few options here on how you want to get started. Here I'm showing you the click-to-deploy solution. To get there, you'll go to Products and Services menu. We're going to go down to Marketplace. Okay, and you'll just search for Fluid-Slurm GCP. Now we have 3 solutions available for you. They all have the same basic infrastructure. Essentially, you're going to get a login node for yourself to access. You'll have a home directory, and then some other shared directory for like collaboration with your colleagues. And then you'll have access to a Slurm job scheduler on another virtual machine called a controller. And then what's going to happen is once you're logged into the system, you'll be able to submit jobs, and the compute nodes to execute those jobs will be spun up on the fly as needed to execute your workloads, and they'll be torn down for you automatically. Now, all that infrastructure is the same across these 3 solutions. The only difference between them is either the base operating system or some of the base packages we provide for you out of the box. On the top, we have what I'll call our classic solution. This is Fluid-Slurm GCP with just CentOS 7. Of course, it has Slurm installed, environment modules, and then we've also added SPAC and Singularity to this solution. Now, the Ubuntu solution has the same thing, except it's based off of Ubuntu 2004. And then the Fluid-Slurm GCP plus OpenHPC is pretty much identical to the Fluid-Slurm GCP CentOS, except we've added a number of packages from the OpenHPC repository. So if you're looking for running applications that need NetCDF, HDF5, Scalapack, Trilinos, any of those sorts of tools that are covered underneath the OpenHPC package management system, this is a good solution to start with. It also comes with the environment modules, Singularity. The bonus, it does come with Charlie Cloud as well. So if that's if you are working with Charlie Cloud for your containerization, that's a good solution. I'm going to go ahead and just pick the basic Fluid-Slurm GCP CentOS. Once you click through, go ahead and hit launch. And then I'm just going to walk you through this form here to help you configure your first cluster. So under the deployment name, I'm going to go ahead and just call this demo. You can call it whatever you want. Essentially, this is just going to identify your cluster in Google's deployment manager, which is a system that will keep track of all the resources that are created from this process. This name will also be the prefix for the login and controller, which when we get to the Compute Engine UI, you'll see what I mean. Now the zone you want to deploy to, if you're not familiar with Google Cloud, the way Google provides access to resources to you is through, so whenever you create a virtual machine, it has to be deployed to a particular data center, or you have to request where you want to launch it. And Google divides its data centers into regions, which are groups of data centers that are geographically close to each other, and zones. And so each one of these zones is a different data center in that region. A good best practice is just to pick a region that's geographically close to you, just to minimize latency between your system and your login node, your controller. And then I'll show you down the line here, out of the box, we're going to have everything deployed in one zone, but we're going to do some customizations after deployment so that you can start to scale your compute nodes globally. I'm going to pick US West 1. This is out in California. Today we're just focusing on default networking, but if you do have your own custom network, this is where you would go ahead and select that out from the drop-down menu. I guess this is a good point to say that, in addition to picking a zone, every virtual machine has to be deployed inside of a network and really inside of a subnetwork. And a subnetwork is just a virtual private network that's tied to a specific region on Google Cloud. So as I mentioned, you'll have a login node. This is where all your users will primarily SSH into to interact with the Slurm job scheduler, probably do some text editing, compile their codes, what have you, do a lot of lightweight work. This is a shared resource across all your users. Now you can have multiple login nodes if you have a large enough team and that's needed. You can increase that beyond one if you want. To be honest, I haven't gone up to like 100 or anything like that, but you can pick a number of login nodes here. They're all going to have the same sort of features here, so it's very homogeneous when you launch out of the box. The machine type that you choose here, really on Google Cloud, what you're picking is how many cores and how much memory am I going to make available to users on this system. Ideally, you're picking at a bare minimum of like a standard 8, and this is really just to make sure you have sufficient network bandwidth. So the deal is the performance or the network bandwidth caps on Google Cloud are really determined by how many cores you make available on your system. And that really goes up to a certain point. Once you get past 32 cores, everything is fairly level for the N1 instances at 32 gigabits per second. At a bare minimum, we do recommend standard 8s, which gets you about 16 gigabits per second network bandwidth. And this will also impact file I/O performance. But for the login node, since out of the box, the controller is actually hosting your home directory and other shared directories on the system, the choosing cores based on file performance for the login node is not necessarily that important. And then certainly the size of that boot disk, since the login node is really just housing the operating system for the login node, you don't really need to make it too big. I'm going to leave it at the standard 4 just because this is a demonstration, but just keep some of those performance considerations in mind. Now the controller is a little bit more it does a little bit more heavy lifting. Of course, it hosts the Slurm controller daemon. So when people submit jobs, it's processing those jobs, creating resources, and then communicating with the Slurm database daemon, which is also on the controller, and then doing a lot of those transactions to the Slurm database. Additionally, is hosting your home and apps directory. So this system you usually want to make a little bit bigger if you have a pretty active team. And again, the bare minimum we recommend is standard 8, just so you're getting that at least this 16 gigabit per second network bandwidth. Of course, you can go bigger, and again, out of the box, the boot disk size, it is going to be important here if you're just planning on hosting home and apps forever on the controller. You want to make sure you have enough space on that controller to host everyone's home directories. Now, if you don't make this larger at first, it's okay. You can use other solutions like File Store, which is an NFS service from an NFS server solution from Google that you can attach to this cluster after the fact if you needed larger home disk space and something that would live beyond the cluster as well. So just keep those things in mind. And now we got down here from the marketplace, you're going to create one Slurm partition. And a Slurm partition really is just a grouping of compute nodes that have certain rules about how jobs are prioritized and how much time these jobs are allowed to run for. Now, what we're going to create is one partition with one grouping of machines in it out of the box, and when we get onto the system, we're going to customize this to give you multiple types of machines, so you can go multi-zonal, multi-regional, or if for some reason you wanted to go heterogeneous in one partition. You'll also be able to add other partitions down the line. Like everything we're giving you here is fully customizable, but what you're going to do out of the box is fairly bare bones, but should get you off the ground pretty quickly. I'm going to go ahead and call this partition the demo partition, and then we got these next two options here: the static node count and the max node count. So the static node count is the number of compute nodes you want to have the deployment create with it. So we're going to create the controller login node. If you want to create compute nodes out of the box, you can increase the static node count above 0. Now these compute nodes will never be taken down by the controller daemon, ever. They will always be there, and the upshot for having something like that is if you don't want to wait the 30 to 90 seconds for a compute node to be provisioned from Google Cloud when you submit a job, having some static nodes around can help alleviate that little bit of wait time. Now, that being said, you're also paying for any of that idle time when those compute nodes are not running jobs. So, typically for the type of stuff we do, which is really on the R&D side, we don't have time-critical applications running. I usually keep these 0, but you might have a justification to make this not 0 and have a sort of a pool of compute nodes always ready to go to accept jobs. So, and then outside of that, you have what's called the max node count. So this is the maximum number of nodes you want to be able to burst out to in this machine block that we're going to be building out. So here I have 0 compute nodes. I'll be able to use a maximum of 10. And jobs will, as jobs are submitted right now, these compute nodes will be created on the fly and taken down when they're idle for too long. So the machine type, again, you're picking cores in memory here. For the demonstration, I'm just going to pick standard 2s, but you got a lot of variety available here. You have N1s, which I highly recommend you look through Google's documentation on a lot of this, but the brief overview is essentially the N1 E2 versus N2D versus C2. All these are just different chip models, chip manufacturers, and of course choosing these for your application is an incredibly important process to make sure you're getting the most out of Google Cloud dollars that you're spending. Again, for the demo, I'm just going to choose N1 standard 2s. And you'll notice right now it says the GPUs aren't available in the zone you selected, and that's really because this menu is tied to the zone we picked up here. And so if you want everything in the same zone and you want to have GPUs in that same zone, you'll want to go back up here and change that zone. Take a look through Google's documentation on GPUs. They give you a nice listing of the zones GPUs are available in. Of course, if you're not tied to having compute resources in the same zone as your controller login node, again, after deployment, I'll show you how you can do some customizations to, you'll be able to have GPUs on the same cluster, even though your controller and login are in a zone where GPUs aren't available. And then for the boot disk, I'm going to leave those where they are. I have no reason to have larger local disk space on the compute nodes for what we're doing. So we'll go ahead and hit deploy. And this brings us to the deployment manager page, which essentially what's going on in the back end is all the solutions we provided for you, one, they're image-based, so we've created images for the controller, login, and compute nodes for you. They're publicly available, and then when you're going through Marketplace, we've provided also what's called infrastructure as code that's being executed in the back end to create the controller, login node, and if you have static compute nodes, those compute nodes as well. It's also hooking everything up to the proper networking and getting all that stuff set up for you. Now, in terms of like what you might think about an analogous scenario here, is oops, did I skip a slide? Yeah, I did. What's really going? Yeah, so if you were to think about what you're traditionally doing at an on-premise system, to get an HPC cluster, you're going through lots of negotiations. You're basically testing out different systems, and then you're finally making this purchase, and then you're putting together the team to bring in all the hardware, set it up, and then keep it running doing your benchmark and your acceptance testing, and essentially this whole provisioning side is kind of taking care of this first half of that deal. I mean, right, you're running in the cloud. The hardware is already installed at Google. We're basically just putting in the software packages and everything you need to make it look like an HPC cluster. So while this is going, let's talk about what we're going to do next here. You're going to SSH into this cluster, and we're going to SSH into its login node. Now, if this is your first time on Google Cloud using OS Login, it's very likely you have somewhat of a wonky username, a Linux username. Essentially, it's going to be your email address, except you're going to replace the @ symbols and the dot, any dots in your username, with underscores. So if I'm someone@gmail.com, my Linux username is going to be someone_gmail_com. This applies for G Suite users as well. If your organization hasn't done anything special with customizing how OS Login works, you'll have the same thing. So, when I first got on, I'm Joe at fluidnumerics.com. I was Joe_fluidnumerics_com with my Linux username. Now, for those of you who are in G Suite or are using Cloud Identity to manage your profiles, you can use the admin SDK, which is available in Python, or there's a lot of different ways to reach the admin SDK or the admin API to customize your POSIX information. And so you'll see today, like my account is just Joe at it's just going to be Joe. That's really it. Okay, so it looks like we're all spun up here. So what we're going to do is we're going to SSH in. I'm going to show you how to get some of the Slurm accounting started here. So we're going to just basically register your Linux account with the Slurm controller daemon and the Slurm database so that you're allowed to submit jobs. And I guess I'm going to pull up one more panel here so you can get an idea of what the Compute Engine user interface looks like. Go ahead and open that in another tab. And you'll see on the deployment page we do have the controller IP address and the login IP address that you can use to SSH in. Let's go back to that Compute Engine UI. And there you are. You got your login and your controller. And again, those external IPs are there. You also have internal IP addresses, which are assigned just within the subnetwork that these things are deployed to. So you can have communications over just that subnetwork rather than over the internet. And then you have the Zonus deployed too. All right. So I'm going to go ahead and log into that login node. So I'm going to snag. If you hover over that IP address, you can copy that IP. And let me go ahead and SSH in. Cool. Once you're in, you'll see the Slurm message of the day. And you might see a message like this. Don't worry, it's benign. Nothing to worry about there. Let's take a look around, see what we have available. If you run the sinfo command, this will show you what partitions are available on your machine currently. So we have the demo partition here. We got 10 nodes in that partition. Here's the node list. And you see out of the box, the node list really the name prefix for all these nodes is the same as the partition name. But as you'll see as we go forward here, all these features here are going to be customizable for you. The node is in an idle tilde state. So one, idle means that it's just not currently running a job, or it's not being drained or being anything else. It's idle. It's not doing anything. Now the tilde postfix here on that name just means it's in what's called a cloud state. So Slurm knows that it can create that node when it needs to and power it up, essentially, and put some work on it. But the first thing we need to do is to create some or add yourself to the Slurm accounting. So I put up the commands up here on the top right just in case the terminal doesn't show up clearly over the live stream here. But in order to run cluster services, which is a command line tool we've baked into all of our images, you're going to need to go root. And the way cluster services essentially works is we work with a dictionary that we call a cluster config, where you can set all the things you want to have on your cluster, and then we use cluster services to parse that and manipulate other things on your system so that you can have other partitions and change your users on the fly, or add luster or NFS mounts after the fact. So let's go ahead and go, whoops. Let's go ahead and go root, so sudo su. And then if you were to run through the cluster services help, you'll see there's a number of commands. We're certainly not going to go over all of them, but just know that you have this reference there always. So as you're learning how to operate this system, you know where to find some additional help. So first thing we're going to use is a command called list. And you can list 3 different types of things on this cluster. You can list partitions, you can list mounts, so these are your NFS, Google storage buckets, luster mounts that you have on the cluster, and you can list the Slurm accounts. We're going to list all because we want to basically create a complete configuration file, and then we're going to modify that and then use that modified one to update the cluster config. So we're going to list all config.yaml because the output's going to be in a YAML format. So let's take a look at that. So you can see you got the compute image, which this is actually pretty neat. In a few weeks here, we'll be showing you how to make your own custom compute images. So if you wanted to like tune an image, or if you wanted to have your own applications and data sets pre-deployed on virtual machine images, you can do that and swap this out here and have your own image. And then for now, the controller login information is really just for informational purposes, but down below is where all the magic really happens. We have our mounts. Again, if you want to bring on luster or NFS or GCS buckets as file systems to be used on compute nodes and login nodes, we can work with that, but that's not going to be today. There's partitions, which we'll get to in a little bit here, and then Slurm accounts. This is where we want to start. But you'll notice we just have an empty bracket here. We've also provided some commands with cluster services to where you can generate valid sample blocks for each of these sections, for your mounts, your Slurm accounts, etc. We're going to sample the Slurm accounts, and I'll show you what that looks like on the screen first, and then we're going to append this to the current config file we have. So here's the schema for Slurm accounts. This is really basic. Basically, the idea is you'll append this to the cluster config, and then you'll customize it for your setup. Okay, so we're going to sample Slurm accounts. You can use the double right caret to append this to the config.yaml. Okay, let's go ahead and open up that config, and there it is down at the bottom. So I'll put on line numbering here to help in case you're trying to follow along. We're going to take the Slurm accounts from line 43, drop it down below. Okay, and let's go ahead and remove those square brackets. For the allowed partitions, right now we only have one partition, so I'm going to set mine to demo partition. You'll set that to whatever your partition is named. For the Slurm account name, so Slurm accounting, you just need to give that Slurm account a name. So if you have multiple accounts where you want to group different sets of users, this might be application driven, or you might have some set of users that are only allowed to use X number of compute hours, etc. Like you'll want to think about how to do your grouping, and that's a whole nother conversation in itself. But for now, let's go ahead and we're just going to give it an account name. I'm going to keep it easy. We're going to call this demo account, and then your users, you're going to list just the Linux usernames that your users have. So again, if this is your first time, you'll have that wonky username with like the domain that usernames attached to. So for my organization, I just have Joe, and I'll go ahead and put Guy in here just so you can get the idea of how we can do multiple users in one account. All right, so that's looking good. Now we're going to use cluster services update, and again, just like with list, just like with sample, you can update all. You can update mounts, you can update Slurm accounts, or you can update partitions. For now, we just want to update Slurm accounts. Okay, and we're going to do config equals config.yaml, and highly recommend before you make any changes to your cluster, always preview those changes, and this will just give yourself that step to breathe and double check that this is all looking good. So let's make sure we have no typos in that partition name. Got demo partition here. I've got demo partition there. Demo account. It's looking good. And then I've got users Joe and Guy. So I'm going to go ahead and apply this change. All right. Cool. So everything's done there. And if you wanted to verify that you now have yourself in the Slurm account, you can use the S Account Manager tool. You can run list users. S Account Manager is one of the command line tools that come with Slurm. I've got users Guy and Joe, and they're both on the demo account. So we're set up now to be able to run jobs. So I'm going to go ahead and get out of root, go back to just being Joe. And we're going to use the srun command to run a single, what's really called a job step. We only want to run, I want to just spin up one virtual machine for you and then convince you that that virtual machine is in fact running on Google Cloud. So I'm going to have it print out the host name. So we're going to say N1. Now, normally, I recommend everyone just, be verbose when you're making commands, which is why I've included the partition name here. But let me go back one step here. If I run sinfo, you see the demo partition has an asterisk next to it. That just means it's the default partition. So if one is not specified in any of these commands, that's what it's going to use. For the sake of just being verbose, I'm going to include the partition name. So we got demo partition, and then we've got account equals demo account. Once you have those two there, you can give it the command you want to run. If you have a longer set of commands, you can either I would just recommend using like a batch job with a script. But here we're just going to run hostname. Okay, so let's refresh our compute engine UI so you can see what's going on here. All right, so now we've got the demo partition 0. Compute node is coming live. You can see it's deployed to US West 1C. Essentially, the Slurm controller has asked Google, hey, I need this compute node. Google is starting to provision it for us. It will pull our compute image out of the box. So remember that compute image key in the dictionary there. It's going to use whatever image you have put there. Now, you could think about what's really going on here. Is normally when you're on premise, you submit a job. Sometimes you have to wait in the job queue for things to go through, and that might just because when you're on premise, you have fixed capacity systems, and sometimes the job scheduler just can't find the resources you're asking for. In this case, there's quite a few resources on Google Cloud, and basically all you have to do is wait for these nodes to become live, which, for our CentOS solutions, we've seen everything from like 30 seconds to 90 seconds for these nodes to be provisioned and to begin responding back to the controller daemon that they're ready to execute a workload. Now the upshot is with the ephemeral nodes is once they're live, and as long as they stay live, the queue time is negligible, and so you have a little bit of a tuning parameter to play with on this system. So once the job is done being executed on this compute node, it will sit there in an idle state by default for 5 minutes before Slurm decides to take it down. Now, if you wanted to make that shorter, there is a and I'll show you when we get back into the cluster config. There is a variable you can tune there to change that amount of idle time you want to have there. If you want it longer, you can make it longer. If you all these things are tunable, and I think that what it comes down to is really a cost optimization thing for you, is whether or not you basically want to be spending all your money on actual compute cycles and work productivity at the end of the day. And of course that one parameter you have there certainly can influence you one way or the other. So at this point you could see we've gotten a response back that compute node's reported its hostname. It's demo partition 0. Okay, if I run it again, you can see it goes immediately through with almost no wait time. Right? So the next thing we're going to want to do is we're going to want to customize these compute partitions to deploy to multiple zones. So right now everything is in West 1C, but you know, you might think about a scenario in which, hey, well, what if this data center goes down, or what if I wanna spread things out just because maybe I'm running out of resources in one data center. You want to be able just to have that option ready for your users to use, so you can expand to other Google data centers. All right, so to do that, we do need to get out of the login node, and we need to hop into the controller. So I'm going to go back to the Compute Engine UI. If I hit refresh there, there we are. We're live. We'll go ahead and copy that IP address for the controller, and we'll SSH into that. All right. So I'll leave this next slide up while we're kind of going through this. Again, you see that config YAML's there, and this is because the home directory on the controller is NFS mounted to home on the login node. So those files will be persistent across all your compute resources. Again, to do this, we're going to go ahead and go root, and we're going to modify that config YAML. So first thing I'm going to do is hop down to the bottom here. So this suspend time, this is that other parameter I was telling you about. So right now it's at 300. This is specified in seconds. This is the amount of time a compute node can sit in an idle state before being taken down. So if you wanted to play with that, that's where you do it. Cool. So what we want to do, let me turn on my line numbering again, is within the partitions block is take the machine block. We're going to duplicate it, and then we're gonna modify that duplicated machine block so that we can have another set of machines in another zone. So I got 14 lines, 15 lines to grab for that machine block. So I basically copied from zone up to disable hyperthreading. And down here, I'm going to say we want to go to West 1A. And just to make it obvious to my users where this compute instance lives, or where it will be deployed on Google Cloud, I'm going to give it USW1A in its name. Now let's go ahead and change the name on that first one there as well. So we'll have demo USW1C. All right, that's it. Let's run that cluster services preview command, but this time instead of doing Slurm accounts, we're going to update partitions. Going to give it this config, and we're going to pass that preview flag. So you can see the first machine block in that partition has its name changed from demo partition to demo US West 1C. And we have another machine block that's brand new. And the name of that is demo USW1A. And then the zone is US West 1A. So I think we're good there. I'm going to go ahead and apply those changes. Give it a quick second. Alright, so now if we run sinfo, you can see we still have the demo partition. Now we have 20 nodes, because now we have two machine blocks with 10 nodes each. Hit demo USW1A, demo USW1C. And now the deal is the original compute node that came live, the demo partition -0 compute node, is no longer under the control of the controller daemon, so we'll need to actually go ahead and manually power that down, so it's not going to be left there after this. So make sure you check the box next to demo partition 0 again. Always double check, and then go ahead and delete that instance. Oops, looks like we lost my terminal here. Give me 1 second. Might need to pull up another terminal here. Give me 1 moment. There we are. Let's give that a go. Make this a little bit bigger. Sorry about that. These things happen when we go live, don't they? And let's go one more. All right, that's close enough. And then it looks like now I just lost my cloud console. So let's get that back up. Not sure what happened there. There we are. Okay, sorry about that. Now, let's go ahead and get back into... All right, so at this point, we've configured the new set of partitions. We're going to go ahead and get back into that login node and submit a job across multiple zones. We'll go ahead and SSH Joe at... Go to that login node. Okay, so again, let's take a look at what we have. All right, we got those 20 nodes, demo USW1A, demo USW1C. Yeah, what we're going to do is run the same job we did before, except we're going to have 2 tasks this time. And what I want to have is 1 task running on each of those nodes. And Slurm has a command, it has a lot of commands for doing what's called task affinity, which is essentially placing where you want all these tasks to run. We're going to use something fairly simple here, which is say n tasks per node equals 1. And I'm also going to give it a node list so I can actually pick and choose which nodes I want to run on. Okay, so I've got demo USW1 A-0 and then demo USW1-C-0. And then all I'm going to do is run the host name, so you'll see now 2 responses come back, 1 from each node, each of them showing its host name. All right, so let's refresh that console. And you can see demo USW1A is coming up, USW1C is coming up, and then of course now they're split across the 2 different zones. So, while that's coming up, let's talk a little bit about why you might want to do multiple zones. You know, as I've said a little bit before, Google has data centers worldwide. And data centers that are geographically close to each other are said to be in the same region. And if you have compute nodes in the same region, you do get a little bit of a performance hit if you're hopping between data centers for doing communication. So if you really have some serious performance consideration for like MPI jobs, ideally, you're running everything in the same zone. However, you know, it is nice to have this sort of fallback when a single zone might, it might run out of resources, or, you know, during peak hours, things like that. You want to just be able to quickly have a fallback plan, somewhere to run, because certainly losing a little bit of performance on an application might not be as expensive as losing a little bit of work productivity. So there's a lot of things to take into consideration here when it comes to making these choices. But you know, when you have these multiple zones, it essentially gives you access to more compute resources, and it gives you a little bit more redundancy. So that you're always up and running no matter what. This is what we call high availability. So, you know, this might be something you want to have. So while we wait, since we're waiting for responses to come through, my slides are not updating now. Let's take a look here. There we go. Boy, all sorts of trouble in these morning ones. All right. It looks like we did get a response, so we'll go ahead and just jump ahead here. Hang on one second. Okay, I think we're back now. A little bit of technical difficulties on our side here. Okay. Sorry about the interruptions there. Let's pick up. So we just submitted a 2-task job with 1 task per node, spread across 2 different zones. And you can see we've gotten responses back from this node here, demo USW1A 0, and then demo USW1C 0. And of course, as I showed you in the compute engine panel, well, if I refresh this, both those nodes are live and in the zones we had wanted them to be. So what we're going to do next is we're going to expand a little bit further. We're going to say, okay, well now, what if we wanted to go to multiple regions? I mean, certainly you could imagine if I go, well, multiple zones, if I go multiple regions, now I have even more compute resources available to me. This also opens up some performance issues, which we'll talk about here in a minute, but let's get through the practicalities of how we would do this. It's going to be very similar to what we did before. We're going to go ahead and get out of the login node. We need to go into the controller. So we're going to SSH into our controller instance. Okay. Now that we're in the controller instance, we're going to go ahead and go root. Let's take a look at the config file. All right, we're going to do the same thing we did before. We're going to copy this block. I'm going to turn my line numbering on again. We're going to copy this block from lines 40 down to 54. Okay, and we're going to paste it down below. Now, after you've pasted it, we're going to change the zone. I'm actually going to show you. We're going to do this in Europe. This is over in Belgium, and as I said, US West 1 is over in California. We're going to go to Europe West 1B. Now, on the name, let's go ahead and change this to EU West 1B. Now, remember before I said that compute instances have to be deployed within a subnet. Now, on Google, subnets are tied to regions, so you can't use the same subnet you were using for West 1A as you would for Europe West 1B. We actually have to use a subnet in the Europe West 1 region. Now, if you're using default networking, this is pretty straightforward. If you look at the end of this URL, you have the project ID, where that subnet's hosted, and then regions / the region where it's hosted. And with default networking, you already have a Europe West 1 subnet, so you can just change the region from US West 1 to Europe West 1. Now, if you're using your own custom networking, you'll want to make sure you plug in the correct subnet there. Okay, let's make those changes. Let's again preview what we've got here. So we got update partitions, preview, and now it's going to add us another machine block for us. The name of that machine block is demo EUW1B. We've got the VPC subnet set to Europe West 1 and the zone set to Europe West 1B. So that's looking good. We're going to go ahead and apply that change. Okay. So if I run sinfo, so now you see we've actually got these two nodes are starting to power down, which is what that % means. And then we've got now really a total of 30 nodes. But 28 of them in an idle state where we now have this Europe node. So let's go ahead and get out of the controller. Let's go back to the login. Okay. And now we're going to run a job across 3 nodes. One in West 1A, one in West 1C, and then one in Europe West 1B. So in California and in Belgium. So pull up that srun command we did before, except now we're going to change the number of tasks to 3. And then on the node list, since these US West 1 nodes are actually powering down, I'm going to just increase this, so I'm looking at using the next node in that partition, or in that machine block. Say demo EU W1B. And we need a -0. So we're going to use one node in West 1A, one in West 1C, and then we're going to use one node in Europe. I'm going to have it, again, print out the host name just to show you that we are indeed running on those nodes. So you can see them becoming live. Here's our node in Europe, and then here's our other node in West 1. And now what you're going to see happen here is that the node in Europe is going to end up reporting its host name last. And the reason why that happened is because that node has a lot more data centers to get through. Physically a longer path for that network information to reach the controller to say, hey, I'm live, And then it's also a further path for that standard output from running hostname to reach the controller and really reach the login node so that it can be printed to your screen. So you'll always see, in this case, the Europe West 1B response come back last. And that's really just because, again, it's in a different region than where your login and controller are. So if we think about this, this idea is essentially by having nodes in different regions, you now know that between those regions you're going to have a higher latency than if you were to have the nodes just in the same zone. You might not want to deploy an MPI, a tightly coupled MPI application across multiple regions. Ideally, you're keeping it in the same region, and in the most ideal situation, in the same zone. Now, if you're doing like high throughput computing, and you can have your data sets or wherever your file is happening localized on your compute instances, or if you have file servers that are replicated across regions, you might be in a scenario where doing high throughput computing is actually pretty nice when you have multiple regions. One, because you have an enormous amount of compute resources available to you, and as long as you can mitigate or work around increase the latency issue between data center regions, you'll probably do really well with a setup like this. Now, this latency problem, of course, is not just for communication. It is for file I/O, which is why I mentioned that like you want to have a file server that's going to be in the same region as those compute nodes, or you could have whatever input decks written directly to like your compute instance images, things like that. If there are ways for you to like decouple like the output process or somehow ship it back to wherever you need output from your codes to go without dealing with that latency problem, you should be all right. But I guess the takeaway I want you to have from here is deploying things between regions, whenever there's that communication there, it's going to increase the latency, and so you just need to keep that in consideration. And of course, for tightly coupled MPI applications, keep them in the same zone if possible. And you can see all three instances reported back from West 1A, A and C, and then Europe West 1B. If I run it again, waiting for resources. What are we waiting for? Oh, they might be, the Europe node is probably still trying to tell the controller daemon, hey, I'm completing this job. I might have been too quick on the push there. If we run sinfo, yeah, the Europe node is still registering as this, hey, I'm still completing work, so it's still trying to tell the controller that we're waiting there. All right, let's go ahead and move on. We're going to go ahead and just tear down this cluster. Is essentially at this point you've gotten the mechanics of how to customize your partition so you can go multi-zone, so you can go multi-region. And so you're now in a scenario where I think you could do quite a bit of hefty computing on Google Cloud. I think the next things you'll want to be thinking about are file servers. Where am I going to deploy things specifically, and those types of decisions. But for this demo, if this is where you're going to be leaving off for today, if you do want to tear everything down, you can go ahead and do that. What we're going to do first is power down those compute nodes. So we're going to say scontrol update node, and then we're going to give it that node list that we have for the nodes that are currently up. So West 1A 1, demo, USW1, whoops, C1, and then demo EU W1-B0. And we're going to tell it we want to put them in a state of power down. This will tell the controller to go ahead and basically it'll reach out to Google and say, hey, delete these instances. So if I go back and refresh the compute engine page, right now they're powering down. And the last thing you want to do, let's go back to that deployment manager page and hit delete. Okay. And that's about it there. So from this point, if you do have any questions, I'll hang here for a few minutes and answer any questions you might have about this cluster, anything we talked about today, or anything you would want to see in the future. And so while you're typing up your questions, I'll go ahead and just share with you a few community resources that are available. You can get all of our help documentation is publicly available. Whenever you use our clusters, we want to make sure that you can get off the ground, you can be up and running with your application quickly and correctly, and you can find a lot of that information on how to do that at our help.fluidnumerics.com/slurmgcp. Underneath there, you'll also find some code labs that we're constantly trying to work on and put out new things. So if there's ever stuff you want to see done here on a live stream or put into a code lab, just reach out to us. And of course, anytime you need support, if there's anything ever an issue with these images, we want to hear from you. We want to make sure that you're able just to focus on your science, and we want to be the ones who deliver the best possible systems that we can. You can reach us at Fluid-Slurm-GCP at fluidnumerics.com. This will post issues and questions to a public group, a Google group, where we will provide our answers and feedback to you publicly so that everyone can benefit from those interactions and the solutions that we put back out there. I hope that you got a lot out of today, and we do hope you join us again. If you wanted to find our complete schedule, again, if you're at the help site, just look under live community training. You'll see a calendar there that you can subscribe to. You can also subscribe to our YouTube channel so that you're always up to date on new live streams and new videos that are coming out to help you just stay afoot of what we've got going on over here. Generally, these live streams will be held at Thursdays at 4 p.m. Mountain Time, Fridays at 9 a.m. Mountain Time as well, every week. So again, I hope you enjoyed what we had to show for you today, and we'll see you next time.